In this video, I'll be discussing the white cane in more detail about the types of canes available, how they are used, and how I will apply the movement to my project design. I will also touch on other object detection techniques I have researched that will be useful to implement in my project. White canes are used to warn the blind of drop-offs and obstacles in front of them. The cane is held forward centered in front of the body with the dominant hand. It is normally held with a golf grip or with the top part of the hand facing upwards and the index finger pointed down the cane. Users swing the cane tip in an arc with a wrist or finger movement, while the arm remains still. The cane moves with the rhythm of the user's feet, tapping or sliding the cane onto the opposite side of the forward foot. For example, if the left foot is forward in front of the body, the cane tip will be on the right side. Two techniques are widely used to provide protection and information of surroundings for the user as they walk. The constant contact or trailing technique slides the cane tip along the ground and can be used to navigate corridors. The most commonly used touch technique is where the cane tip touches the ground at each end of the arc and remains no more than an inch above the ground. White canes are generally 3/4 of the user's height, reaching just below the armpit when the cane tip is vertical to the ground. Canes are manufactured with various materials such as fiberglass, carbon graphite, and aluminium to reduce weight and provide different levels of durability. White canes come in three forms: straight, folding, and telescoping. The straight cane is the best type of cane for visually impaired individuals learning to travel. Its length and ability to bend slightly provides lots of sensory feedback. Normally made out of fiberglass or graphite, it is lightweight and durable using a metal tip, making it great for traveling long distances. The straight cane's length is a downside and can make it difficult to use in a crowded area and hard to store. The folding cane is well suited for active visually impaired individuals and compactable, making it easy to store or dismantle when entering cars or restaurants. The folding mechanism increases the number of materials used to construct a cane, making it heavier, causing fatigue in the wrist and back. This makes the folding cane less usable for traveling long distances. The telescoping cane is compact and extendable with additional length adjustment. Their light construction and compact design makes them easy to carry around and use actively for long distances. But over extended use, the wear and tear can cause the rubber plug to become less effective at securing the cane in the retracted position. White canes are fitted with tips that are manufactured with different materials. Each type of tip provides a different level of feedback for various surfaces. Most commonly used are pencil, roller, marshmallow, and metal glide tips. The pencil tip provides good feedback and its lightweight eases the strain on the wrist, but the tip's long, thin shape gives it a tendency to get stuck in cracks along the sidewalk. The roller tip rolls over cracks in the sidewalk, providing smoother travel, but the added weight increases the wrist fatigue and decreases sensory feedback. The marshmallow tip is thick and less likely to get stuck in cracks, but the additional weight can cause wrist fatigue over time. The most used metal glide tip is very lightweight and glides easily over sidewalk cracks. It will last longer than a nylon tip and give good feedback about surface changes. In my previous video, I briefly spoke about time-of-flight scanning and using its equation to calculate the distance from the user or scanner. Pulse-based LiDAR scanning is when a pulse of light is sent from a transmitter. The pulse light travels and bounces off the object and then returns to the receiver. The pulse travels at a distance of 2d and it takes t units of time called time of flight, at velocity c, which is the speed of light. To infer d, we transpose the equation to make d the subject, which is 1/2 of c times t. This is a key idea for time-of-flight scanning. Due to the arcing of the cane when the visually impaired operate the cane, I may need to incorporate the acceleration and deceleration of the movement in the calculations. I have been researching additional methods of object detection and came across OpenCV, an histogram of oriented gradients technique. OpenCV is a computer vision library with APIs that let you set up a pipeline for your computer vision project. It gives the ability to load data from images, videos, and capturing devices such as webcams, which can be analyzed and manipulated. OpenCV contains a list of algorithms used to detect edges that can be applied to projects. Additional open source libraries like NumPy, Matplotlib, and Mahatas can be implemented to support large, multi-dimensional arrays and plotting. OpenCV and Mahatas rely on NumPy arrays for additional functionalities, and all these libraries can be utilized using Python programming language on a Linux operating system. Histogram of oriented gradients is a dense feature extraction method for images, extracting features for all locations. The hog feature descriptor converts an image of size width times height times 3 channels to a feature vector or array of length n. The distribution of directions of gradients, x, y derivatives, and magnitude are used as features, giving a lot more information about edges and corners in the image. These libraries and feature descriptors can be programmed and loaded onto a Raspberry Pi microcontroller connected with a camera. The camera can take photos every 5 seconds as a user walks, and the image can be processed to detect obstacles using the classifiers. In conclusion, I hope to try bundle multiple techniques into my prototype to give the best possible form of object and collision detection for the blind. Over the coming weeks, I will begin to put my ideas into practice and build a prototype once my parts arrive. Here is a list of references and guides used for research and to learn and operate OpenCV.